Get this show on the road. Good morning, everybody. I am Lisa, your host this morning, and I have my co-host Jennifer. Give a little wave there, Jennifer. We will be your vision room hosts, and welcome to 3D printing for students with visual impairments, resources, and considerations for the classroom. Today's session is being recorded, and we will share that through the Past Project YouTube channel in a few weeks. It's also being live captioned, so if you need access to that, it should be in your toolbar at the bottom of your screen. Out of respect for the other attendees, we have all the participants muted for the time being. If at any point in time people want you to talk or speak up, or we'll let you know, so just unmute yourselves. If you have a question though, for the most part, if you could type them in the chat box, we'll make sure to keep track of that and get them to Neal as he goes through his presentation, or at the end, probably, if there's not too many at a time. We'll share those questions then. In order to earn your CEUs, you'll be needing an ending and a beginning code for this session. The beginning code is students, STUDENTS. Our presenter is Neal Mckenzie. He is joining us from the Sonoma County Office of Education in California and is an expert in adaptive technology. And I'm going to turn it over to you to get us started.
All right. Well, welcome everyone on this. Where I am at, it is very early. We're looking at 5:30 a.m. But I'm glad to be here with all of you. Today we're going to be talking about 3D printing for students with visual impairments, resources and considerations for the classroom. And I really hope the resources can immediately begin to help yourself and really direct student outcomes. Because there are a lot of great resources out there. And I think for the most part, through this presentation, most of the resources are free, especially for ones that are working with students and clients who are blind and visually impaired. So like was mentioned, the begin code is student, and we will get started. So my name is Neal Mckenzie. I am an assistive technology specialist. I work for the Sonoma County Office of Education here in California, which is typically a great and beautiful place to work. These last couple months have been a little shaky, not only the pandemic, but we were riddled with a bunch of scary fires. And actually the last few days, we had extreme fire weather watch. So I was really hoping that this was all going to work out, and thankfully nothing extreme happened. So I'm very happy to be here. So I work for the Sonoma County Office of Education. We have a lot of districts in Sonoma. So we serve over 40 different districts. And I think what's unique about my position, and I haven't really met someone else who does AT specifically for a VI department. That they don't work directly with the SELPA, but they specifically work with the VI department. So we started that position years ago, kind of a trial, and then we're actually lucky to hire another one just because it has become so overwhelming and such a needed part for our department. Personally, I think what has made me really effective is I started as a paraprofessional for academic blind student. And I have used that training and that skill set throughout my career, went back to school, did what I need to do, and I'm currently AT specialist. And I think in all the caseloads here in Sonoma County with our VI department, we have around 140 blind students and visually impaired students, K through 12, some older ones in transition. So what I wanted to do, maybe really quick, if we could put in the chat, know what some of your roles are. And also if you have had any experience with 3D printing before we kind of get into the meat of this. So if you can put in the chat, maybe what your role is. So then I can kind of be a little with this presentation and really speak to the ones in the audience, especially since we have a smaller group. I think that would be really beneficial. So I'm going to stop and then check the comments to see where people's roles are. TVI, not much training in 3D printing. This is perfect. O&M, teacher in AT for 6 school corps. This is great. O&M, teacher of the blind and low vision. Perfect. All right, so it looks like we have a lot of TVIs, which is great. Teaching assistant. Oh, 3D pens. We're going to be talking about those too. Oh, Bev. Hi, Bev. No 3D printing experience. All right, perfect. So we got a very good mix, which is great. So to get started, I kind of wanted to where we're kind of coming from. I am not a CAD engineer or a 3D professional, but I do work in a department that facilitates access to school curriculum for students who are blind and visually impaired. And so that's kind of where we're coming from, because we kind of want to show a real life example of using this tool with that population, and really how successful we were, even though it was a learning curve, but how great of a tool this could be, especially for ones that work with this population of clients. So how it kind of started for us was this big push for tactile and spatial access. And this is something that happened early on in my career when I was teaching voiceover on the Mac operating system. And a student asked me if there was any way that I could come up with a tactile diagram of the desktop. And honestly, when that request first came in, I kind of brushed it off and was thinking that it wouldn't be useful enough to produce. But she was really adamant about it. So this was a high school academic blind student. So I said, why not? Let's give it a try. And so this is what's pictured on the slide. It's a tactile version. And this is obviously from years ago, because even the icons are old. And it really completely changed the way that I would teach tech forever, and really showed me the importance for that tactile spatial reference. Because once we brought out this teaching aid and we went through even what a pull down menu was and what it looked like, and then even going through the icons, we realized that there was so much importance in all these things. And the student was the one who came up with the idea of why it could even be called a dock. We had this back and forth of, oh yeah, it's kind of like boats are always at the dock. Sometimes they go out to sea, but they always have to return, and that's where they stay when they're not being used. And it kind of reinforced all these basic computer ideas. And even the pop-up window in the middle, the yellow window, that was something that could be taken off and put back on, had Velcro on the back. And it just really informed us on how important it was for us to supply these tactile diagrams and references for our students. And it's something that our department has really pushed for, even during this pandemic, where we are completely remote until December, but to have that chain of these tactiles going out for our students. And it really has made a huge difference. Now, included in the references, I'll give a whole list of and links of all the references at the end. But one of those will be, we have come up with a bunch of teaching diagrams that can be used in conjunction with the Piaf machine. I'm sure a lot of you are familiar with that, pictures in a flash. It's the two-part where you can print something on specialized paper, then run it through a machine, and then everything in black, the black ink will raise to make it tactile. So we have teaching aids, and this idea was kind of brought about by that. We continue that. We even have one for Google Drive, Google Slides, Zoom. That's been a big one. Audacity, and it's only become more apparent the need for these references and these tactiles. And that's a lot of our low vision students too prefer tactiles, even when they're doing math diagrams and activities like that. Their eyes are rest and build up those tactile skills. And once again, all these references that I'm going through, if I'm going a little too fast, we will have them all ready for you at the end. One thing that we thought, we saw this emerging technology, especially 3D printing, kind of centered around the maker movement. And as we kind of explored this, we realized that a lot of ones in this field, especially TBIs, thought of it as completely what they do. But the more we thought about it, the more we realized that TBIs are kind of like the original makers. They've been asked to do this almost every single day. Hey, can you take this 50-year-old photocopy and somehow make it accessible in a completely different way? And what we have pictured on the slide is a TBI holding up a model of a DNA for a blind student who is exploring it with his hands. And so we realized this was such a perfect marriage, even though a lot of the times it's considered as different, but TBIs have put so many things together and have been asked to do that in a real little amount of time. Realize that TBIs, AT specialists, VI support staff, alt media specialists, ones who are blind, ones who are visually, do this on an everyday basis. And depending on what tools they have, that's what they will come up with, whatever they have around. And they are so resourceful in this. And it's kind of awesome to think about the original maker movement as being really TBIs and all the ones in this field. I kind of want to ask at this point, maybe you can put it in the chat. What was the last thing that you made, or maybe that came out of your department, that either really helped the student or you were just really proud of? Whether that be something to help with math, something to help with science. What was the last thing that you made? And maybe it was on the tactile side that you were just really proud of, or you made accessible. It doesn't even have to be tactile. It could be something you did in a digital format. And we'll look at the chats to see what ones have come up with. Math cards. A tactile and braille layout of a Chrome keyboard. I got to ask more about that after. And these are all, again, examples of things every day in departments. Tactile classroom layout, that's a perfect example. Tactile communication board for the classroom. You guys are awesome. A reproduction of an abstract painting a student was supposed to analyze. Map preschool section of the school. These are all brilliant examples of TBIs being, a forefront of the maker movement. So go back to sharing. All right, those were great. Those were great examples, and I actually want to ask some more questions about those examples after. I'm always looking for resources. And I think the thing with like those examples that were just mentioned in the chat box, they're solutions to real world problems. Sometimes we see these mock-ups of things that were 3D printed or engineered. And some of them are really cool, but you can tell there's a lot of times where they're missing the key ingredient, where it's just not a solution to a real world problem. It's not connected to someone who's impaired. Their voice is nowhere in. So it's just a perceived problem, but not a real problem. So really, us in this field have an advantage of really getting that voice directly in, because a lot of the designs that have come out of our department were based on real life problems. Some of the designs that were 3D printed from S.C.O.E started with, hey, I have this situation with a student. How could we use a 3D printer in this, or would this be the best use of it? So We're going to watch a little video now, and we're going to look at some of the designs that have come out of our department. And then we're going to kind of go back to how this can be accessible to multiple departments. But this is kind of just a little show and tell of some of the designs that have come out of our department. Again, through that collaboration directly with the students, us as a department. So we'll go ahead and look at that.
We designed the Braille thingy to help make learning the Braille code fun and exciting for students who are low vision or completely blind. Here are the parts to this design. The sheet. This thin 3D printed sheet has 6 cutout boxes on top of 6 cells, all containing 6 circular holes. This sheet works along with an all-in-one board and can be easily secured by 2 large clips that can be found at any office supply store. The next part is the holders. These are small 3D printed boxes that fit onto the sheet. They contain magnets on the back and small clips on the top and bottom in order to hold flashcards. We used PIF printed flashcards cut to the same dimensions as the boxes, which includes the printed letter along with the Braille dots. Small columns with rounded tops were 3D printed to make the Braille dot used for the sheet. They have small magnets underneath to help secure them to the board. There are 3 main ways to use this system. 1. I used the word game as the example here. Place the desired flashcard letters onto the boxes and place them in the empty box slots on the board. Next, have the student place the 3D Braille dots into the corresponding holes in the Braille cell directly underneath each letter box. 2. When a low-vision student is ready and no longer needs the Braille prompt, simply take away the boxes and write in whatever word you would like them to practice. And once again they will fill the corresponding 3D printed Braille dots in. 3. Have the student use the empty Braille cells as a guide to fill in the appropriate dots to whatever word is in the boxes. And voila! They have created and learned Braille in a new, exciting and fun way.
Mobile masker. 3D printed base the size of standard letter-sized paper. There are slits running down both of the long sides that work as a track. A piece of paper can be slid onto the base and a mask fits onto 2 small pieces that fit into the tracks and allows the masking to move as you read. Quadrant math grapher. This is a 3D printed base about 9 inches by 9 inches with a thin raised border all along the sides. There is a thin piece of corkboard that is cut to size and glued onto the base to allow the placement of pins. Next, there is a thinner square that fits on top with the help of 4 circle cutouts that correspond with 4 small columns on the base. This top piece contains a 4 quadrant graph with an X and Y axis. We even developed a corresponding graph paper that can be placed in between the top and bottom plates so that the plot points made by the push pins can be visually seen on the print copy of the graph paper. Single quadrant grapher. This is built off the same design as the quadrant math grapher. The only difference is that instead of 4 quadrants there is only 1, allows more room to plot on a specific quadrant. Depending on the placement in relation to the user, any of the 4 quadrants can be represented at one time. Hole coloring guide. We 3D printed out a simple sheet with different sized holes that can be clipped onto one of those amazing all-in-one boards by APH. This was to help these specific students who had mobility and muscle control issues be able to track and produce a piece of artwork as independently as possible. We also made backing coloring sheets using the guide. This fish's name was Hootie. Finger pencil holder. We are working with a visually impaired student who depends almost solely on one finger to write and draw with. We found a print that someone was using as a customizable finger splint and made a custom pencil/crayon holder that he could use in conjunction with these activities and IEP goals. Map of our office. This is a 3D printed map of our office. Here's the kitchen and that's where I work. Note taker model. A blind student was going to present his Braille Sense U2 note taker to his class and asked me if there was any way to make a small model of it using the 3D printer. I at first told him I couldn't, but then realized how proud that idea made him and took my best shot. He loved it and requested about 610 to pass around. He was so happy to have a model of something that was a representation of a real tool in his life. Mini portable light box. We mixed this awesome print using Brain Enigma's box design, added lid support and customized tops for sorting activities. We have used them with some of our CVI kids and they love the customizable high contrast sorting games that ensue. We added a remote controlled light that can change color and intensity with the press of a button at Amazon for around $5. It's also good for when the classroom is lit. Rotor box. This is a simple model that can be used as a tactile demonstration when teaching the rotor gesture for voiceover. Once you print the 2 pieces, simply slide on the small circle to the middle of the big square and it spins very nicely, perfectly mimicking the rotor finger movement on an iOS device. Also helps students to realize the circle matches up to choices. Isn't voiceover great? I think so.
Okay, so that was kind of a demonstration of a lot of different prints that have come out from our department. And again, based upon students' real needs and issues. Let's talk about first how we got our, and we're gonna really discuss how you can really get 3D prints without having to house and learn how to get your own 3D printer. There's a lot of free resources out there that we're going to go through first. How we did it is we proposed it to our low incidence committee. And to be honest, I did not know how that was going to go. I wasn't sure if it approved because this was years ago and it was still so new. We knew the potential of this tool, but we still weren't seeing a lot of departments utilizing it at that point, and it was still fairly new. So we were hopeful, and we were really happy that happened. But we went in there with a pretty solid case, and that is also kind of part of this whole thing too, is to build a case for presenting to maybe different departments or to get funding. Or donations to have one of these in your own department or where you service clients or students. But again, you don't need to have access. And you can start finding local maker spaces in your area. And I would do this anyways because it's kind of a great collaboration process. And you'll be surprised how many there are. When I was first getting into this, I tried an exercise where I just typed in local makerspace, and there was one blocks away from the office where I am right now. And they're so willing to collaborate too. I have the definition of a makerspace, a place in which people with shared interests, especially in computing or technology, can gather to work on projects while sharing ideas, equipment, and knowledge. Another good way to get free prints is a lot of us are itinerant. So a lot of us are, well, not so much now, but in some areas going to schools. And so a collaboration with robotics clubs, STEM groups, even local high school math or science teachers, they're really popping up everywhere, and they become more accessible in that way, that so many schools and libraries have them. Scouting organization, we had a local scouting organization build us some tactile and accessible games. They spent months doing it, and they 3D printed some of the pieces, and they donated them for an after-school group that I help run, that all we do is play accessible games. And so that was a great collaboration from the community. And they're actually the ones who reached out to us. We're fortunate because our main offices at S.C.O.E have a huge STEM makerspace, which is pretty nice. And actually, we didn't start collaborating with them until after we got ours and kind of learned the process. But since then, they've been a huge help, and it's really good to know someone who's been through it to tap for troubleshooting issues too. One of the best ways, because now it is starting to become an option, and there are starting to be 3D printers in VI departments and other agencies like this. So if you can find one that's close to your area, that's going to really help build for a better ask. I know we've had maybe 2 or 3 different departments come here to the offices, check out our setup, ask questions, and are really prepared. They want to make the decision if they want to get a 3D printer. So those are options, but there are also some other web-based options that will print out free 3D prints. And one we're going to look at right now is we're going to look at a short video from a resource called S.C.O.E, and she is the one who runs that. And actually, this video was just finally ready on Sunday, so you might be one of the first ones who are seeing this. But C3D is a website that offers free 3D printing, that's so hard to say together, to TVIs and ones in the field. So let's take a look at C3D.
When I was in 6th grade, I decided to teach myself Braille so I could read books in the car without getting dizzy. Being sighted, I was always looking for more reasons to continue learning Braille. I read an article about 3D printing for the blind in 8th grade, and after seeing Braille on models, I realized I could use my Braille skills for this purpose. I also noticed there were so many people who wanted to 3D print, but weren't sure what to create. From there, the idea for C3D was born, an organization that connects people who are blind with people who can print and design 3D models. Fast forward a couple of years, and now C3D Incorporated is a 501c3 nonprofit with a leadership team of 4 and 8 interns. Since 2017, we have distributed over 1,000 models to 15 states and 4 countries. We have showcased at maker fairs, blindness and disability conventions, and virtual conferences, and have been featured in numerous articles, podcasts, and radio programs. We want to connect with more people who enjoy 3D printing so we can all increase the availability of tactile learning tools. If you are interested in getting involved in ways such as designing and printing models, brailing, or donating filament, you can contact us at info@c3d.org, on our website, or through any of our social media platforms. If you would like to place a model request, just check out a request form on c3d.org/request_info.
So that is a great resource because, again, they will ship out via Free Matters for the Blind 3D prints that you have requested. And I know right now they're just starting to gain traction. So this is a good time if you did want to request prints, because they are really quick at this point, and really wanting requests and to get the word out. Like I mentioned, all these different kind of collaborations with maybe within a local high school. A lot of libraries now are equipped with 3D printers. And I going through this process because we were bugging these guys a lot about 3D printing, and I found that very rarely were we told no. We kind of talked about what we wanted to do, and these different ones in the community were really anxious to help us out and to get us 3D prints. Even though, like I mentioned, the local makerspace that was blocks away, we were teaming up with them this summer to have builds where they make tiny rooms for active learners. And they were going to donate a bunch of stuff, and we we're going to get a few of them built, and it was going to be really cool. But with the pandemic, that kind of put things on hold, but we're hoping to start that again. Another thing, just like C3D, there's a few other big request banks that are, again, offering this type of service. And again, all of these will be in the resource sheet at the end. But Ultimaker has one, Can Change has one, Today. And a lot of these, it's really cool because you can even go in there with a problem like Makers Making Change. You can say, well, I have this student who maybe needs a certain stand for, and these are kind of the specifications that they need, and they'll have engineers actually work on it and get you something that you can maybe 3D. A little bit of a longer process, but it is cool to know that these resources are out there, and there's ones that have that knowledge, and then paired with your knowledge as a professional and really understanding your students and student outcomes could really make for some cool things. So let's go back there. So what is 3D printing? Well, in the basic terminology, 3D is obviously three-dimensional, and it's printing an additive manufacturing process that creates a physical object from a digital design. And this process works by laying down thin layers of materials, it's really early, in the form of liquid or powdered plastic, metal, cement, and then fusing those layers together. So that's what we're mainly focusing on, because I think probably 80% of the printers you're going to see are FFF printers, which means fused filament fabrication. So these are the printers that you typically are going to see in libraries, in classrooms. Maybe you have experience with some of these printers, and they all work basically on the same foundation. And that's, they have a filament spool, and that's really, where the product comes from, the filament. And that's, you buy things in the spool, and they come in different sizes, but it's a thin thing of filament, and that filament is led to an extruder. And then once it's fed into the extruder, gears control movement of that filament, which brings it down to the nozzle. And before it hits the nozzle, it's heated up to a certain temperature based on what material you're using. Now, once it's heated up, it goes through that nozzle and it melts that material, and it's deposited in very small layers, and it builds up from that. Also, one of the things to consider too when you're looking at 3D printers, because I'm just reminded of here in this picture, is the print bed size, because that will determine what size prints you can actually make. Ours is about a square foot, and I don't think I had any need to print anything bigger than that, and that's actually a pretty good size plate. I have one that's 4 inches too, that I print off smaller things right here, right behind me. But that is something to consider, making sure that you have a print bed that could handle what you are trying to do. Filaments. We're only going to talk about a few because there are so many, and there's so many different ones that are coming up almost every day. They are Frankensteining these things, and there's a lot of ones that do pretty cool stuff. But just for these purposes, we're going to talk about pretty much the ones that we use. PLA, it's fully biodegradable. It's thermoplastic polymer consisting of renewable raw materials, and it actually is food grade. Not that you are encouraging students to eat your prints, but we do have students that sometimes these prints will go into their mouths. And it's nice to know that it is food grade and it is safe. Not that we are in any way pushing that, but it is nice to know. ABS, it's extremely durable thermoplastic, and they're pretty close, but PLA is probably the least fussy to use, these both being thermoplastics. PLA is a little bit stronger and stiffer, but it definitely doesn't have the heat resistance that ABS has, because I have made maps, and O&M instructors will leave them in their cars and then come to me with the soup thing and ask what happened. And it's because they left it on their dash and it just completely got all melty. ABS is weaker and less rigid, but it's tougher and lighter, and it does have a higher, and it's a little more durable that way. One thing that I just got maybe a couple years ago was a dual extruder that also includes flex. And so flex is made up of thermo, and it's a blend of hard plastics and rubber. And just like the name, it's flexible. It is a little bit harder to use, and it's a lot more touchy. So I don't use it that often, but I have made some really cool prints with it, and the students love that rubberly tactile feel on these prints. So now we're going to talk a little bit. Let's say that you do get approved and now you're looking for printers. Now this is a question I get all the time. What printer? Now, for us, I don't think we would ever say this is the printer that you should get, just because my experience with it is we have a printer, but it's been so long since we've bought one, and that is not something I keep up with. And it's just kind of like anything else, any other big purchase that you've made, you kind of just know what you have. It's kind of like having an embosser. Like, oh, what, I get that question all the time. What's the best embosser? I know the one that I use, and I can use it pretty good. But it's not something that you really have access to a lot of different types of embossers or 3D printers. But there are some guidelines that will help you if you are looking to make that purchase. Some things that and advice that we were given that really helped us. First, research. And it is kind of just like buying a car. You just got to do your research and find out what's going to be the best fit for you. I always put this in here, the Jimmy effect that I used to have, and he's actually getting his doctorate in music in San Diego. But he was deciding on what music program to purchase, and he had a decision between one that was fully accessible or one that he could use enough that was accessible enough, because he's a Braille student and screen reader user. And he made an interesting point for his idea to go with the one that wasn't 100% accessible, but hey, he'd make work. And that was because the people around him, everyone else in the class, was using the other program. So he thought that it would be more beneficial, instead of having to wait for maybe the few people that can give him support on that really specialized program, was to use the one that was being used by everyone around him, so he can really ask for help and support and kind of be more integrated in the class, which is a good idea. So if you know someone who has experience with 3D printers or has one, really pick their brains, because they could offer a lot of support. I have a picture because this is something that someone told us that was extremely beneficial, and that is, unless you're MacGyver, get pre-assembled. So this is the thing with 3D printers. A lot of hobbyists will get these, and it's cheaper too, but it comes completely apart, and it's up to you to assemble the 3D printer, and people really love it. But again, those are hobbyists that have a lot of experience in this. So if you are looking to get a 3D printer, if you know that knowledge and can assemble it yourself, that's awesome. But if you're just starting off, get pre-assembly. You want things to be, especially starting out, as much as it can be plug and play. And what's great about this technology is that even from the time we got our 3D printer, a lot of the things that were tougher on the learning curve, leveling the bed, and even the extruder, have become a lot easier process. Self-leveling and the extruders have become way easier to use. So that's all great, especially if you're just starting out. There is a learning curve, but this setup process is usually broken down into easy step-by-step parts. And that's exactly what we did. We had no idea what this thing was, what we were doing. But we saw a YouTube video and explained exactly how we set it up, and we got it running. And then there's a picture of a man covered in cords, because that's exactly how we felt after going through this process. So let's say that you have a 3D printer. And a lot of the questions are, okay, if you're going to get a 3D printer, if you're going to use this technology, what do you print? Where do you start? And so I have this quote: "If I have seen further than others, it is by standing upon the shoulder of giants." And I think in this field, what's great is that I think we become better for direct outcomes for students, for clients, whatever it is, because we're able to share out, we're able to share processes, we are able to steal other people's ideas and use them directly with the students. And that's one of my favorite things about working in this field, is because there's some fields where you can't do that, you won't be successful. But in this field, really learning from others, this is a good example of that. Being at a conference, it's really beneficial directly to the ones that you are serving or students that you're working with. And so what's great about 3D printing, again, is that when you start, there's so many print resources, meaning there's so many models and prints out there just waiting for you to download and to print out, meaning you don't have to know any CAD, you don't have to be an engineer, all ready to go. So if you have the printer, they have the prints. So right now, I'm going to try to share my screen, and we're going to take a little field trip, and we're going to go to Thingiverse and just look at a few things. And if you want to too, on your computer, go to Thingiverse too, and maybe take a few minutes to look around there. And this is probably one of the biggest 3D libraries. It's www.thingiverse.com. So I'm going to share my other view, and we will look at a couple of things here. So let me get this. All right. All right. So you should be seeing Thingiverse. So this is Thingiverse, and what's right at the top is search Thingiverse. So we're going to do a little search here. Let's do Braille. And we're going to see, and we're going to notice a couple of things too that you want to look at when you're looking at these searches. And there's a lot of cool prints, and again, all these are free. There's the Braille dice. I've used that a few times. We're going to look for something specific though. There's a little slate and stylus. I think it's on 4. All right, there it is. There's actually, I've used that Cutaway Earth with Braille too. It's a great model. But we're going to look at this one. Again, this is the Braille rotor box. And all the prints that we have come up with, this is one that came out of our department. They're all free, and you can download any of them. And again, this is the rotor box for teaching the voice over gesture. So at first, when you click on a model, you want to look at the summary to see if it's, what you want. So the summary says, this is a simple model that can be used to have a tactile demonstration when teaching the rotor gesture for voiceover. Once you print the two pieces, simply slide on the small circle to the middle of the big square and it spins very nicely, perfectly mimicking the router gesture in an iOS device. Also helps ones realize the circle matches up to choices. So next you'll look at print settings, and these first two aren't important because we printed off a Lulzbot TAS5, but whatever printer you use, it doesn't matter. This is kind of the more important thing, rafts or supports. So is this a complicated print that's going to require a lot of setup? Typically, actually, all of our prints are no rafts, no supports, because again, I'm not a professional designer or CAD artist, so I want to make it as simple as possible. And another thing you want to look at when you're kind of deciding to download a print is you want to see if other people have made it and maybe look at the comments. So a print that other people have made and posted shows that it's pretty successful in that it works. And what's really cool is that there's been others that have printed this and they have dual extrusion, wow, I can't say that word this morning. And so they actually made different two colors in one print, which is really cool. And they sent me pictures of this, and I wish our printer had that. But also look at the comments, and then you can see if, it's print. So what you would want to do at this point, if this is a print, okay, this is something that, I'd be interested in. This is something that would be useful. Then you download all the files. You're going to go directly to your computer. And at that point, you would look for, most important one would be the STL file. And these would both be on the STL file, and they'll open in the next program that you would need to use. But Thingiverse is a great resource. And again, we've even used it just for references for animals, for science, for math. And there's a lot of different libraries out there, but I think this is the biggest one. And really, I would suggest that you just kind of explore it, find a print, and again, maybe use those free resources to get something printed for free and sent to you in your department. So let's go back. All right, so that was MakerBot Thingiverse. And there, like I mentioned, there's a lot of 3D model print library resources. Thingiverse is probably the first one that comes to your mind just because it's the biggest one. And again, all these will be in the resources page. Grab, CAD, Autodesk 123D, Yegi, Sketchfab, PinShape. Basically, there's a whole bunch of these free resources, free libraries that you could find different models for pretty much any situation that you might find yourself in. Now we are going to look at blind, visually impaired specific 3D libraries, because there are a few that are great. I don't know if any of you have checked out APH TGIL. It's Tactile Diagram Image Library. Again, this will be in the resources. But they have a huge library of not only 3D prints, but of also POF-ready PDFs, I believe. And you can do a search. Sometimes the site is a little buggy, but you can do a search and you can find those models and those prints again. And once you set up an account, they're all there for you to download and to use. And we have used those in a lot of, especially a lot of school oriented, where we're looking at maybe phases of the moon, or you're looking up different geography maps, and those are there, and they have a lot of great 3D prints. Another one that I like is Be Tactile, and this is, again, it's a huge library. Again, you can get, I believe, POF files, embosser files, and 3D prints. And I think as ones in this field start really using this technology more, I think that has been a huge question, which there really is no specific answer now, of if there could just be a big universal library for these specific prints. And many ones have asked that or started ones, different repositories, but it hasn't really been set yet. So that's kind of a big question in this field, is if there can be a resource that can kind of get all these things together. I know specifically there are some great Thingiverse groups. I have one that a lot of ones have joined, a lot of AT specialists that have made kind of AT specific prints, and different ones in the field. And again, all that will be on the resource page. So to kind of understand this process of how this works, there's a 3D model, and that usually comes from the computer. And we're going to talk about, if you are going to jump into making your own models, we're going to do a little demo of that. But from that 3D model, let's say that's Thingiverse, you found a 3D model, you download that, and you're looking at, specifically for that STL file. Now, once you have that, it has to go through a slicing program, because the STL file is saying, okay, this is what it's supposed to look like. This is kind of like the outside. This is the model. But the slicing program says, okay, this is how we're going to build it. This is how specifically your printer is going to have that happen, all the technical aspects of that stuff. And then it usually will spit out a G code, which is like, okay, now we understand what the model is, how we're going to get this printed. Here's the instructions. And then that G code goes to the 3D printer, and then that 3D printer will work on 3D printing that object. So that's kind of the process in a nutshell of what we're looking at when we're looking at 3D printing. So, a lot of the times we focus on, this is such a good tool, but as with anything, big tool or technological advance, I always ask, well, how can my students benefit from this? How can my students take advantage of that? And we're going to talk about that maybe more a little bit later. But one of the big problems is the slicing programs that aren't too accessible with screen readers. And I know that they're working on that, but that has been kind of an ongoing issue for student-led design, is slicing. And then we're also going to talk about building models. And there is actually an accessible way that students can do this, but slicing is kind of the ones that is being the holdup for 3D printing, because it is pretty easy to make 3D printers talk and to take your students down that road, but there are still a lot of aspects of this process that aren't too accessible, which I hope changes. And it seems like they're on the road to that. But when we're talking about, getting these prints, finding the right ones, we also want to talk about if you want to build your own prints, or maybe even take a existing print, and remix it to make it fit you or your student, or one that you're working with, their specific needs. So one of the easiest ways to do that, especially if you're just starting, is Tinkercad. Now, I think probably a lot have heard about this. It really is. It's a visual-based CAD program that will let you easily come up with designs or add on to a current design. So we are just going to, for a little bit, take a field trip and just kind of get a basic layout of Tinkercad. So let's stop sharing. And let me get the right one down, okay? And then okay. So you should be seeing Tinkercad up here. And this is kind of the building area when you're getting into Tinkercad, and it has all your designs. But we're just going to take a brief look at this. What's great is visually it's nice because you can just start and go, but since it is so visual, it really is not accessible to your students. But we're just going to show how easy it can be to create something. First off, you have a work plane. And what's great is you can put this in millimeters, inches, or bricks, which you can make work with Legos. So I usually end up doing inches. And then for my build plate size, I'll usually do 10 by 10, even those are ours is 12. I never make anything that big. And so then your grid is ready. And let's actually use, oh, yeah, we can use this. So you have a square, and what I like to use is the ruler too, because it gives you direct dimensions. So you know this is 1 inch by 1 inch by 1 inch. And you could either take this button and create something bigger, or you can input the value. So you want this to be 2 inches. And let's make this 4 inches. And you can do it that way. Now the hardest learning curve on this is when you're first working in a 3D plane to get the views right, so you can actually see what you're doing. But it is really easy to make basic shapes and to like here, it's a cylinder, but it's negative space. So when you add these things together, now you've created something with a hole. And it's really simple to, kind of get way more complex with this, and to even bring in designs and to kind of add your own stuff. So that's just a brief demonstration of Tinkercad. And like I said, it takes a little while to get used to the 3D plane, but once you're done with this, it will spit out that STL file, and you can run it right through your 3D printer. Now, I would say one of the things that was messing me up a lot in the beginning is I would create some of these really cool things, but then I would forget that they were not touching the ground, and they would not print because the 3D printer does not know what to do when you ask it to start in mid-space. So that was, I think it took me like 2 weeks of failed print to realize what I was doing there. So that is Tinkercad. So let's go back. So Tinkercad is great, but obviously super inaccessible because it's so visual, and there's really no getting around that. So let's talk about a CAD program that actually is accessible and can be used in conjunction with the screen reader, and that is OpenSCAD. And I have some students right now who are just starting with this, and what it is, it's again, all these things that I've showed so far are free. It's a free software application, and it again creates solid CAD, computer aided design, but it is script only. So it's linear, and it uses its own descriptive language. So by inputting the proper code, what it outputs is different shape lines. And I think there's a big misfire when it comes to reference. that I hope that that part can be fixed, because you could create really complex shapes and designs with OpenSCAD, but until you actually start printing it, you won't realize if it's wrong, or well, you'll realize if the code is wrong, but you can't visually see where you're at, because there is a screen that depicts what code you have put in and what that has created. We were at a conference that was just on tactile graphics and art, and we used the graffiti from APH, which works off of the video card for a computer. And what it does is just grayscales everything and out on this big display that has a big refreshable braille display that can make pictures and make a lot of different things. And so what we did was we used OpenSCAD, we hooked up the graffiti, and we were able to, in real time, create different shapes and then get that tactile reference from the graffiti. So the prospects of this, again, becoming pretty accessible is looking good, but definitely not there yet. One of the, but it is looking like it's going, because I know I have a lot of students who want to design their own 3D prints. They actually are doing a great job starting out in OpenSCAD and using that linear code to accomplish this. One of the things that has been really successful for us is maps. We use two processes. We use the POF, and I create really cool maps with, I use Google Styles, and I can create really quick maps that can be printed out and used with the POF machine, but also 3D maps. And I think especially for when the students go to a new school, they actually hold on to those maps and use it as reference, especially when they're in conjunction with their O&M lessons. And it has been really successful. And our O&M teachers have been awesome about using this in conjunction with new spots. They're going downtown, they're gonna get a map of downtown. They're going to the school, a new school, they're gonna get a map of that school. But I wanted to show you a really great resource right now. We're gonna take another field trip to TouchGrapher. And it's a way that you could get your own specific 3D print of an area for free. Again, you can build it, you can download the file, and it's ready for a 3D printer. And again, this is all offered for free. So let's take a little trip to TouchGrapher, and I'll walk you through the process. And before we got a 3D printer, we were using this to make 3D prints, and they've gotten so much better. The prints have gotten so much better, especially with the data from the maps. So we are going to take a field trip to TouchGrapher. Once I switch this, let me get there, and I will. Sorry, did I say TouchGrapher? TouchMapper. And let me share the screen. All right, here we go. All right, so you should all be seeing TouchMapper. Create tactile maps easily for any address. And it is extremely simple, which is great. So it's as simple as entering an address. And what's great is you don't even need to enter a specific address if you know the area name. So example we're gonna use is Santa Rosa High School, which is right down the street. And we search. All right, so there's a couple parameters now that they're asking to fill out. So they found it. It's 1235 Mendocino Avenue, Santa Rosa. Now you get a choice. We're obviously interested in the 3D printing, but you can also do embossing or swell paper, which is really cool. But we're gonna do 3D printing. And the first question it asks is print size. So if you know how big your printer bed is, this will fit pretty much any of them. 5.1 inches, 6.7 inches, or 7.9 inches. So again, our printer bed being a square foot, we'll go 7.9. And then here's kind of the most important, the map scale. Now they have a default, but you can go in or you can go out. So obviously going out is a lot of information, and just like making any tactile reference, you really got to be careful of putting so much in that it doesn't even make sense, or maybe the design is too complex. So we're going to go to default, but let's see how close we can get. This is if you just wanted the school grounds. That's actually a decent map there, but let's just do default. Content hide buildings. And what's great is when you get more advanced, you can build multi-part maps. So you can do a pretty large map, and let's say you do it in 4 parts and put it together, and you could fit a lot more information on those maps. But that would take a lot longer. But let's just do the default, and let's see what happens. So we're going to do create map, and it'll take a little bit. So we could order it there, and I think it's just a small price for shipping, or print the map yourself, which is what we have toggled on. And we're able to download a printable STL file. And that's actually a really good looking map. I at first had to make this exact area and build it myself. But now we have a map that's ready to go. And again, you could have someone else print this for you, for your student, or if you had access to a 3D printer in your own space, you could 3D print it, and it's all ready to go. You put it in the slicer, and then you make that G code, and you are in business. So let's go back. And that's been one of my favorite resources. And again, all these will be in the resource page. And we've been using that one for a lot. Now we're going to just show a very brief video, kind of on some of the most successful prints we've had when dealing with STEM or STEAM.
This is Mario. He's an 8th grade, very academic, and extremely quick on his feet blind student. Mario, like so many other kids, thrives in a setting where he is challenged and motivated by a particular school assignment or concept. But also, like many other kids, Mario finds it easy to disengage when the assignment is dull or not accessible. Here are 3 examples from this year that have really taught our whole department just how useful 3D technology can be in bringing concepts and assignments to life through inclusive tactile models, especially for STEAM, science, technology, engineering, arts, and mathematics. Example 1, train switcheroo. Mario was handed a washed out, inaccessible photocopy of train switcheroo. Train switcheroo is a multi-step math problem with many moving pieces, which includes 1 train, 2 cars, a tunnel, and a barn, all with their own set of rules. The objective is to follow those rules and complete a series of moves which will bring the train safely into the barn and switch the position of the cars. I was able to find very simple representations of the train and the cars on Thingiverse and build a quick tunnel in Tinkercad. By using the Piaf machine to make the tracks, what Mario was now given was a tactile, inclusive, and truly engaging assignment. By adding print and braille to the board, Mario could work with any peer in the class side by side to tackle this problem. Kids ended up fighting over who got to do this assignment with Mario. Example 2. Scaling dilation. Mario was struggling with the overall concept of scaling a dilation in math. A dilation is a transformation that changes the size of a figure. It can become larger or smaller, but the shape of that figure does not change. This spatially is a very confusing concept, and even when done on a piaffe or embosser, is at best a 2D representation of a 3D model. By constructing this very simple model, Mario instantly connected with this concept and understood the unit at a new level. Example 3. Dating the fossil record. This was a big unit that focused on being able to tell time periods based on examining fossil records. Mario's amazing aide pulled me aside again and gave me a washed out photocopy of this assignment and said, okay, how can we make this accessible to Mario and how can we make this fun? By making the main 9-panel fossil record a 3D printed tactile model, which included a tactile key in print and braille, the kids were again fighting for a chance to work with Mario on this project. Adapting these assignments showed us not only the potential of this tool, but the ability to make inclusive learning that was better for all students.
So those were some of, I think, some of our best use of the 3D printer. And what was great about going through some of those specific assignments was collaborating with the classroom teachers, and those assignments never made it out of the classroom. So the teachers just saw the benefit kind of overall to add that tactile piece to these assignments, and ended up taking them and just using them in the class, and realizing it was just a more engaging way to teach. So that was really cool because all those examples never made it back to the office, and in fact are still being used in the classroom, whether or not there is a blind or visually impaired student there. So with 3D printing, it has been such a great tool for us, but there is a lot of things to consider. Just like with any tool, any new tool that you get, and going back to that idea of, teachers, TVIs and ones in this field being, some of the original makers, once you get those tools, you got to, kind of decide when that tool is used and what's best use of that tool, because there are a lot of pros and cons to 3D printing, and when to best use that tool. Some of the cons are that it is a learning curve, especially if you're looking to start making original designs. But again, once you start, that eventually gets easier. Unsuccessful prints. Sometimes you put a lot of time into something and get back to the office and it looks like a troll doll or something, which actually my students love the failed prints. They have asked to be brought every failed print because they love tactilely all the things that it does. So happy with failed prints, but they love them. Again, time too. It does take time for these prints, and that's a factor. And then fortunately, I have a great brailleist in our department. That's typically always here, not now, but usually. And she does a great job of just keeping an eye on the printer while I'm going back and forth to different schools. But that's also a factor. Some of the pros, the low cost of raw material, it's awesome. You buy those big spools and you can make a lot of different things at a very little cost when you're talking about those. Once you do have a successful design, it can be duplicated, it can be shared out, it can be used over and over again. And as we looked at, there's a whole growing library of these prints. And I think one of the best things is the ability to design with specific student needs in mind. So there are a lot of things to consider when 3D printing, but it is exciting to be in this field right now and to see this tool being utilized with students, and to just see the number of tactile references go up, because I do feel like there is a hole there. I'm not even talking about 3D printing, but of tactile references for our blind impaired students that should be being filled, no matter really the extra effort or time it takes. And they should be getting used to having those references available, which currently is not always the case. So I hope that this was informative and you learned a lot. There's the end print. And now with the last 15 minutes, I would love if there was any questions, comments. There's the resources, there's the link. There's also my Twitter. I share a lot out of things that I'm working on at Neal_AT. And I hope you guys enjoyed that. Yeah, so I will see if there are any comments or questions. Okay, there was a question. Or are those available to purchase? What specifically was that? From Casera. Carissa.
Okay, she popped up here later, Neal, and said, first of all, that this was amazing. And then something about the items in the video. That was pretty early. I don't remember
Oh,
the video.
yeah, all the items in the video on that resource page, there's a Thingiverse link, and they're all available free of charge to download and print. None of the prints that we have come up with or made are for sale. They're all for open source, so you could utilize those. Oh, I don't know if I put the resource page in the handouts, but I will do that. I'll put the link to. Should I send that to you, Jennifer? The resource page?
Yes, that's fine.
Okay, yeah, to make that available, because that is the. Oh, I have seen the Project Core. We've used that within our SELPA 2, so we're using it across O2, and that's really great. So I see a question, do any of these services help with coloring sheets for preschool students? Is there a way we can get Susie to elaborate on that? Fantastic presentation. I need a 3D printer. They're pretty cool. Does the mapper website have schematics for the insides of buildings? So that's, Dawn, that's a great question. And they do not, but I have recently been getting schools and building 3D models off of that based on room layouts. That's a little more advanced process, but it is hugely beneficial for our students. So Mapper does not do that, but what's nice about schematics is you can kind of break it down to the most simple form, and you can build them pretty easy in Tinkercad. I have, let's see, preschoolers who are asked to color things, but think I should have a tactile. Okay, Susie, what a great question. So we do use the PIA, and we are constantly making coloring pages. And like we have a student now, dual media learner, failing vision, probably will be completely Braille student early on. So they have a whole set of these coloring pages for a specific character that kind of goes through a bunch of different sections in class, and we have made tactiles of all of those, so that she can color those, and those for reinforcement have been great for her. And we do that for a lot of coloring pages. So what's great about coloring pages is they're usually, if you can get the file where it's usually just the black outlines, and it's usually easy to make those too. So yeah, that's a great resource, and it's a great tool that we've used specifically for our younger students for coloring. So that's a great question. And I think even APA coloring books too that are tactile. But it is also kind of nice to be able to make your own, specifically what the student's going through in class. So. Thank you all for joining. So I don't know if you said this, but what 3D printer would you recommend? So, the ending code is print, I believe.
It is.
So I wouldn't recommend a specific printer just because it's been so long since I've purchased one. We have a Lulzbot TAS 5, and it's like a workhorse. But that was years ago, and the technology keeps on getting better. I said it was just like, I always get that question, what kind of embosser? We got 4 years ago that we use like a workhorse. So I would never suggest a specific printer, but I would just look at reviews and do your research on that, because the technology changes so quickly. What was the name of the website that made street maps for you? Touch Mapper. And again, I'll make sure that I send the resource page, and all those resources and all the links are embedded in that page. That's Touch Mapper though. Specific features we should prioritize. You guys have come up with some great questions. I would say self-leveling bed, because I get in trouble with that a lot of times and I have to readjust ours constantly. That would be a big one. And dual extrusion is nice, but I would say self-leveling and pre-assembled. Get pre-assembled unless you want to build your own 3D printer for the first time, which I would not suggest. I must have missed hearing that earlier. Oh yeah, no problem. Oh, and again, Patricia too, if you can find others, ask around locally what ones are using. And that's what we did. We asked our local maker spaces, asked our local libraries, and we were put in the right direction. And when we needed help, we had someone down the street. Thank you guys so much. And I hope that you found this all I can't wait till we can all be at conferences together again in the same room. I'm really missing that now. So the plastics are actually the cheapest part of the system once you have it going. So they are, our LI committee still buys us when we run out of the spools. They last a long, which is great. So you'll buy one and they last, even though we have ours running, our spools last quite a long time because it actually doesn't take that much filament for a print. Printers are great. Yeah, I think everyone's missing the in-person conferences. Hopefully next year. All right, so I will make sure right after this to upload that resource page because it has everything on there. What is the approximate shipping time for when I order 3D animal representation for preschoolers? What are you ordering them from? Where are you ordering them from? So that would depend on where you are ordering them from. But the nice thing, that's where we started out. We started out with 3D animal representation. That's how we started printing. I did not know how to print at that point, so we needed basic animal representations. And even though we had some ordered, it was quicker to 3D print our own because you have them in a day as opposed to, if you source those out. I think an ox was the first thing that I printed because my student was getting annoyed because everyone's like, oh, it's just like a cow. It's like, well, I don't have a reference for a cow either. So that helped. That helped a lot. All right. Thank you, guys.
Okay,
That
looks
was
like
awesome.
all the
I'm ready.
looks like the questions are done. That was great. Thank you so much, Neal. Don't forget, guys, to complete your evaluation to get your PGPs or your CEUs and to be entered into a prize drawing at the end of the conference. And I know there's some great things they're giving away. The evaluation link can be found in SCED or it was provided in the chat box a couple of times. And don't forget the ending code is print. Thanks, everyone.